Data structures are one of the fundamental concepts in computer science. In this video, I'll define what a data structure is, give you some real-world analogies, and talk about a few things you should know about them. Data structures can be defined in many different ways, and every book or every online resources will probably define it somewhat differently. The way I define it here is that a data structure is a representation of data for retrieval and manipulation. So the key word here is representation, how you represent the data. Now in the physical world, we have data structures. You can think of maps as the data that represents our world, but it's projected onto a piece of paper with lines and labels. It's representation. We also have dictionaries, our basic words of our language organized in a lexicographical way for quick retrieval. Filing cabinets, how we store files in folders for quick retrieval or making it easy to add and remove files from our filing cabinets. And libraries, what does a library represent? Well, a library can be thought of as a container for books with shelves and card catalogs in a way that facilitates very easy retrieval. So you can look up where a book is in the container or where it is on the library bookshelves. For the librarian, modification is necessary. So the librarian can add new books, replace damaged ones, or remove old ones. Now in computer science, we represent data in many ways. There's the primitive types like integers and floating point numbers, individual characters. We have strings, which could also be thought of as arrays of characters, depending on what we need that representation for. And then there's linked lists and more complicated data structures like graphs or trees, hash tables, often called associative arrays or dictionaries. In C++, a hash table could be the unordered map. We have bit fields and objects. In C++, these objects would be classes, structs, or unions. Now, some of these data structures or data types are defined more abstractly, like a graph. So we can talk about a graph and maybe algorithms on it or structures of it, how it's organized in nodes and edges. And we can talk about directed graphs or undirected graphs, but we don't have to talk about its specific application or how it's implemented. So we can talk about it in a purely abstract sense, which is very important for data structures, at least some data structures. Now, some most commonly used data structures are often stored in reusable libraries. These code libraries, for example, like the C++ standard library, the Java collections framework, and the Microsoft .NET framework, let the working programmer use these data structures without having to rewrite them for every project. So code reuse is very important with data structures. Now, we often represent our data structures in terms of how efficiently we can use them, such as storing and retrieving data. So we want to quickly retrieve the data, and we want to minimize the amount of information needed to store it. And we want to be able to add, edit, and delete data and operate on it very efficiently. Now this will conclude this introduction to data structures, but remember, when thinking about data structures, the key word is representation. A data structure is how you represent your data.